In this example, what we're going to be doing is looking at determining functional relationships with different representations. So part A, we are given sets of ordered pairs, and we want to determine which of the sets of ordered pairs represents a functional relationship. So when we're looking at a data set that's presented in this manner, what we want to focus on are the input values. And if we have any repeated input values, then we have a problem with that data set representing a function. So if I'm looking at this first data set, I see my inputs are -3, 5, and 4. And what we have then here is a function because each of those inputs is unique. If I look at my second data set here, I'm looking at inputs of 0, 5, and 5, and this is a problem because here in this ordered pair, 5 is associated with the output of 1. Here, the input 5 is associated with output of 4, so we do not have a function here according to our definition of a function. Looking at the third data set, I have inputs of -3, 5, and 4. These are all unique inputs, and it doesn't matter that they're all associated with the same output because the rule for function is that for each input, it's associated with a unique value for the output with one unique value. So this one is a function also. I'm going to do the same kind of thing looking at table values. I want to scan down through my input list. If any of them are repeated with different outputs, I have a problem. So with this very first table, 4 goes to 41, 4 goes to 30. That is a problem. I have a single input 4 associated with two different outputs, not a function. Looking at the second table, all of my inputs are different. So I have every input is associated with a unique output, good for a function. Same thing then on part 3, 0, 1, 2, 3 are my inputs. Does not matter that all of my outputs are the same. What matters is that each input is different and is associated with only a single output. So that is also a function. Now when we get to graphs, what we're going to be looking for is the same idea, but graphically we are looking to see if we have any ordered pairs that line up on the same vertical line. Because if we do, then that means we have the same input with a different output. So if I look at this first data set, if I draw a vertical line through each of the ordered pairs that I'm given, I'm only going to hit one ordered pair. So this graph does define a function. Same thing with the second one. If I look at the graph here, any vertical line that I draw will only intersect the graph in one place. This is also a function. And then the last one, if I look at the graph here and I draw a vertical line, I'm going to intersect this graph in multiple places, meaning I have the same input associated with multiple outputs. That is a problem for a function. So this one is a no.